So example 4 for participant A in example 1, what is the ordered pair RISI for the estimation interval 38-39? So member A, remember in example 1, member A, the YI and the ZI. YI and ZI is 34.75 and 38.75. So the interval estimate is 38.9. So we draw the timeline. The interval estimate is 38 and 39, x and x plus 1. So YI is 34.75 before the x, and ZI is after the x, in between the estimate. So this is the interval estimate, and this is the exit the entry and the exit age. So they share some point here. So they share some point here. So YI before the x. When YI is before the x, RI is 0, and the ZI is in between x plus 1 and x. So SI will be between 0 and 1. So how to determine the SI? So ZI equal to 38.75 is equal to x plus SI. So x is 38. X is 38 plus SI. So SI is 0.75. Therefore, RI and SI for member A is 0 and 0.75. Let interval estimate 35 and 36. So we still use the YI and Z for member A. So YI and ZI for member A. So this is the interval estimate. This is x and this is x plus 1. So YI is 34.75 and ZI is 38.75. So this is the entry and exit age. So they still share the same point, so it contributes. So when YI is less than x, RI is 0. When ZI is greater or equal to x plus 1, SI become 1. So for this condition, RI and SI for this interval estimate equal to 0 and 1. Okay, let interval estimate for the third one as 29 and 30. So if we draw the timeline, the interval estimate 29, 30. So this is x plus 1. This is the interval estimate. However, YI is 34.75. And ZI is 38.75. So the entry age and the exit age is outside the interval estimate. So they do not share the same to any point. So they do not share any point. So this case is not contribute for this estimate. So member A not contribute in the interval of 29 and 30. Okay, let's do the example 5. So member D, in example 3, you have to determine the ordered pair for the interval estimate 30 to 31. So member D, remember, the yi and the zi is equal to 26 and 30.47. This case, the member D die in the observation period. So the schedule, so the first schedule, we estimate that he will finish up until the end of the observation period. However, he died at age 29.69. So the death happened before the end of observation period. So how to determine the RI and the SI for this estimate? Okay, let's say we draw the timeline. So the entry age, the interval estimate between 30 to 31. So this is the interval estimate. So the entry age is 26. So yi. So we have two zi here. So we try the first one. So the schedule one, zi is 30.47 somewhere here. So zi for schedule. So how to determine the RI? So for schedule, RI, SI is, since RI, yi is less than x, RI become 0. Zi is between this interval. So it must be between 0 and 1. So how? Zi is x plus Si. So x is 30 plus Si is 0.47. So for death case, RI and SI, death case, the death is happen 29.69. So for this case, Zi is 29.69. So it before the interval estimate, so it's not contribute to the interval estimate of 30 to 31. So for the schedule one, it contributes. So the estimation of QX can be simplified into 3 special cases. Okay, for special case A, RI is 0 and SI is 1. Special case A, RI, SI is 0 and 1. We classify it as 0 and 1. For special case B, where RI is zero to 1, when it happens between the interval, and S1 is 1 when it's greater or equal to x plus 1. And special case C, Ri, Si, where Ri is 0 and Si is between 0 and 1. When Zi happens between the interval of. In case 2, participant 1, I give you the example. In case 2, participant 1, the Ri, Si is 0.5 and 1. This one we classify as special case B. So now we go to definition of observation period. So for example, observation period begin at birthday for Yi, and also the boundaries and also the Zi end at Okay, now we go to definition of observation period. For example, observation period begin at birthday, which resulted in an integer value for Yi. Then, if x is also integer, it follows that all Yi occur at estimation interval boundaries so that Ri is equal to 0 for all I. Similarly, Si equal to 1 for all I if the observation period ends on the member's birthday. So it becomes integer. It doesn't have any point behind the Ri and Si because we follow the member birthday. So if the observation starts on a fixed date, however, if the observation starts on a fixed date, so Ri for all members will be greater than 0, same as Si also will be less than 1 if it ends on a fixed date for all members. So the first one using birthday, member birthday, it will become Ri and Sy become integer, and this is we use fixed date. So Ri and Si will be between Ri will be greater than 0 and Si will be less than 1. Okay, let's do the example 6. So we have 3 members here. We have the information of the observation period from 1st January 2005 until the member's birthday in 2006. 3 members all in the study group as 1st January have the following date of birth. So all the member in this group join the observation at 1st January 2005. So you have to determine the special case for the interval estimate 2021 and also 21 and 22. So member 1. Is joined 1st January 2005 and exit at 1st April 2006 because we follow the date of birth is 1st April in 2006. So member 2, they still have the same date of join until 1st July 2006. And member 3, 1st January 2005 until 1st October 2006. So how to determine the Ri and Si? So let's draw the timeline for member 1. So to determine the Yi and Zi, remember we need 3 basic information. So The date of born is 1st April 1984. So date of birth 1st April 1984, and he starts joining on 1st January 2005. Start the observation period and also join. The observation is on the same date and end at 1st April 2006 because end follows the member's birthday. So the interval estimate so yi, how to determine the yi? So yi is here. Yi is at age, okay, let's say 1st April 1984 until 1st April 2005. Member 1 is 21 years old. 21. So the difference between here, he is 3 months. So yi become 31 minus 3 months, 3 over 12. So 20.75. So zi is integer because it follows member's birthday. So here he is 22. So yi zi is 20.75 and 22. So the first interval estimate is between 20 and 21. So how to determine the Ri and Si? So 20 is somewhere here. 1st April 2004, 20, and 21 is 1st April 2005. So the interval estimate is here. So they share the same point here. So Ri is yi equal to x plus. So Ri is equal to yi plus So yi is x plus Ri. So yi is 20.75. X is 20. So Ri is 0.75. So how do you determine the Si? So Zi is 22. So the interval estimate is 21. So Zi is greater than the interval estimate x plus 1. So Si is equal to since Zi is greater than x plus 1, so Si equal to 1. Therefore, Ri and Si for interval estimate 20 to 21 is 0.75 to 1. Okay, second one. Second interval estimate 21 and 22. How to determine the Ri? So yi is 20.75 it less than interval less than x. When when the yi is less than x, ri become 0 and 22, and zi is also 22. So it become si become 1. So this one for special case B, and this is for special case A. So let's try member 2. So member 2, first July 84, first January 2005, the observation start, and also he joined same date, and the observation end at 1st July 2006. So how to determine the yi's? So yi is 1st January 2005. So 1st July 2005, his age is 21. So the difference here is 6 months. So yi is 21 minus 6 months is 20.5. So zi equal to 22. So zi for member 2 is 20.5, 22. So the first interval estimate is 20 to 21. RISI is equal to 0.5 and 1, which is special case B. And RISI for second interval 21 and for second interval 21 and 22, RI and SI is 0 and 1, which is special case A. Okay, now we go to member 3. So member 3, if we draw the timeline, he was born on 1st October 85, date of birth. So the observation period 1st January, the observation start 1st January 2005, and also the join date until 1st October in 2006, and so yi is until 1st October 2005. His age is 20. So the difference here is 9 months. So yi is 20 minus 9 over 12. So 19.25. So ZI is 21. As the first interval is interval estimate for 2021, the RI and SI equal to, since YI is less than 20 and ZI is equal to the X plus 1, so RI SI becomes 0 and 1. So this is special case A. And for the second interval, no contribution, since second interval happened 21 to 22 outside the entry and exit each. So no contribution. No contribution for this interval.